Hi, Algebra 1. This video covers lessons 7 and 8, and we're looking at how to rearrange equations to solve for different variables. Here we go. We're skipping ahead to activity 8.2. Read the problem, get started on number 1. Go ahead. So I color-coded these to kind of help us out here. If there's 8 volunteers, I could take 2 miles, divide it by those 8 volunteers. Each volunteer would have a quarter of a mile to clean. And similarly, if I had 2 miles and 10 volunteers, each volunteer would have 1/5 of a mile to clean. And you can see that with 25 volunteers, it's 2/25, and with 36 volunteers, it's 1/18 mile per volunteer. In number 2, we want to see this pattern that we've started using and create an equation with it. So write an equation that would make it easy to find, this is L, the length of a road section in miles for each volunteer if there's N volunteers. So I've noticed that in my pattern, I kept taking my 2 miles, dividing it by the number of volunteers, and that would be L. There's my cursive L, the length of the road that they're each going to clean. In number 3, we have the same problem, 2 miles that they're cleaning, except now they're telling us how much each person is cleaning. So if you have 2 miles and they're each cleaning 0.4 miles, that means you would have had 5 volunteers to clean up that amount. Again, I've color-coded my work over here so you can see how many volunteers for B, C, and D that it would take. And then going down to number 4, we're going to generalize these patterns we saw into an equation. So I noticed that each time I was figuring this out, I took 2 divided by the length that each volunteer was cleaning, and that gave me N, the number of volunteers that we needed. The key thing to notice here is that this equation is similar to our previous equation, it's just rearranged. In number 1 here, we're going to do A first. How much water would be in the tank after 4 minutes? So we have 124 liters to start, and we're adding in 9 liters every minute, and we do that for 4 minutes. That would be 124 plus 36, which would be 160 liters. In B, we have 80 seconds. Now, our problem is in liters per minute, so we have to think about how many minutes 80 seconds is, and that would be 1 1/3 minutes, because you'd have 1 minute and then 20 more seconds, which is 1/3 of a minute. And when you calculate this out, you would end up with 136 liters. Now we want to put this all into an equation. And what I noticed is that I was starting with 124, and I always took 9 times M, however many minutes it was, and that gave us liters. We'll call that big L. In number 2, now we're going to figure out how many minutes have passed after it contains a certain amount. So if we have 151 liters, that means if we subtract off what we started with, we've filled up 27 liters. And when we're doing that at 9 liters per minute, that means we've been filling it up for 3 minutes. In B, if we have 191.5 liters and we started with 124, that means we've filled up 67.5 liters. If we did that at 9 liters per minute, that means we've been doing this for 7.5 minutes. I'm going to skip down to D now, and what I've noticed with my pattern is I'm taking however many liters I have, I'm subtracting 124 so I can see how many liters I've filled up, and then I'm dividing that by 9, and that's giving me how many minutes I've used. Now, what's happening here is that this equation is really the same thing as this one, just rearranged to give me minutes instead of liters. All right, here we go into lesson 9, where you're going to continue working to rearrange equations to solve for different variables. Here we go. In lesson 9, we're going to skip ahead to the second activity, where we're looking at the shipping capacity of a cargo ship. So we have a ship that can carry 21,600 tons, cars weigh 3.6 tons each, trucks weigh 7.5 tons each. So in number 1, we're going to write an equation. C is going to be the number of cars. So the total weight of cars is going to be 3.6 tons times the number of cars. We're going to add on the weight of the truck, so it'd be 7.5 tons per truck. And that has to equal our limit, or our capacity. So in A, we're trying to figure out how many cars we can fit if we already have 480 trucks. And so if I go to simplify this, I'm going to have 3.6c plus, right here I'm going to simplify this into 3,600, and then I'm going to subtract 3,600 from each side, and I end up with 18,000 right here. I'm going to divide both sides by 3.6 and end up with C equals 5,000. So if there's 480 trucks, I can fit 5,000 cars. As I look ahead to D here, I notice I'm going to be writing an equation, and I'm going to figure out how many cars I can fit if I have T trucks or any number of trucks. And as I look at what I did right here when I was solving, I ended up taking all of this and subtracting it from both sides. So that means I took the 7.5 times T and I subtracted it from both sides. And that's a legal move. I can do that. I'm left with 3.6C equals, and I can't really line up my equal sign here because I need to be able to fit it all, 7.5 T, and I apologize for it being so squished right there. Then I noticed that at the end here, I divided everything on both sides by 3.6. So I end up with C equals 21,600 minus 7.5 T, all being divided by 3.6. And that's what we are really looking at here, is how can I rearrange that equation to get a different variable by itself, or to solve, in this case, for C. I want you to take some notes from this slide here in your book. We're given an equation right here. This is giving us our total budget, and spring rolls cost 75 cents each, or excuse me, vegetarian spring rolls, that's the V, and shrimp rolls, the S, cost 95 cents each. And we're planning a party here, and we want to figure out how many vegetarian spring rolls we could order, or how many shrimp rolls we could order. And the idea here again is that we're rearranging the equations. So I just want to work through how I would rearrange this equation to solve for V and get this one right here. First thing I would do is subtract 0.95s from both sides of the equation, and I would end up with 0.75V equals B minus 0.95s. There's no like terms that I can combine on this side, so that's all I have. Then I would divide both sides by 0.75, so I end up with 1V, or just V, equals, and here I have B minus 0.95s, all being divided by 0.75. We could use a very, very similar process to solve for S. To solve for S, or to get S by itself, I would subtract 0.75V from both sides of the equation. So on the left, I still have 0.95S equals B minus 0.75V. Then I would divide both sides by 0.95, and I'm left with 1S equals B minus 0.75V, all being divided by 0.95. So now I've rearranged the equation to give me the number of shrimp rolls I can buy, depending on how many vegetarian rolls I bought. All right, guys, nice job working through lessons 8 and 9 here. You're going to be using this idea of rearranging equations to rearrange equations for lines coming up next. So good work, keep it up.